Dear students, today let us try to do the question number 5 of the rotational mechanics. A good question to understand the basics and also a little bit of your Newton's laws of motion application is also involved in this one. See, the question number 5 says something like this for me. We got a uniform rod. Uniform rod is made to lean between a rough vertical wall and the ground. Okay, the coefficient of friction between rod and the ground say for example mu1. Okay, and between rod and wall is mu2. Okay, if the angle at which the rod, whatever the rod we are taking, the rod, sorry, yeah, a rod can be leaned without slipping is dash. Okay, so this is a basic question. We need to find out the angle at which it is being inclined. They might be giving you the options, but I'm not giving an option. Just make sure that you understand the questions. Make sure the way you draw the diagram for this one to understanding is very, very important for us. That's a very important area. First, see the question, what exactly is saying. We got a uniform rod and it is made to lean between a rough vertical wall and the ground. Okay, the coefficient of friction between the rod and the ground is given as mu1 and between the rod and the wall is given as mu2. The angle at which the rod can be leaned without slipping will be equal to how much? Okay, let me draw the diagram for this one. This is your ground. Okay, and if I'm taking the rod, something right now here like this. Okay, so this is the rod which is being inclined here, right? I need not write this whole thing. Why? Okay. Okay, so this is the rod. Okay, and say for example, this is the angle made by this one. This is nothing but of your theta. Okay, now tell me what are the forces on which it will be acting right now. So I'll take one pen right now here. Okay, this is one question. Okay, so this is a rod. This is the point, say for example, of your A, and this one is, say for example, point of your B. So when it is ready to move, that means when it is ready to move on an x-axis right now. So this is your x-axis and this is your y-axis. So when the rod at point A is moving in positive x-axis, the rod at point B will be moving in the downward direction. If I take the forces acting on that body beta, one is the weight of the body that is at the center of mass. The weight W is acting in the downward direction because it is rotating and also making an angle theta and also moving in the downward direction. This is making an angle theta. So at point A, when it is moving in the front direction, you know that obviously the friction acting on this body will be in the backward direction. So that will be equal to your F1. This F1 is equals to mu1 into your N1 because at this point, I will take the normal N1 in the upward direction. Okay, now in the same way at this point there will be the normal right now here, so this will be equal to N2. As it is moving in the downward direction, frictional force will be acting in the upward direction, that is F2 is equals to your mu2 into your N2 in the upward direction at a point of your B. Now from the center, this length is nothing but L by 2 and this length is also equal to your L by 2, center of mass, isn't it? So I hope you are clear with the free body diagram about this one. See, the FBD I have taken very clear, and theta is the angle at which the horizontal angle at which it is ready to slot. Now for horizontal equilibrium, we can say that all the forces in x-axis and y-axis must be equilibrium, because the question says for me, a uniform rod is made to lean between a rough vertical wall and the ground, and the coefficient of friction between rod and the ground is mu1, and between rod and the wall is given as of mu2. The angle at which the rod can be leaned without slipping, so there is no slipping part of relation. So if I say that for horizontal equilibrium, I can write here. So let's say, for example, theta be the angle, okay, at which the rod makes with horizontal, okay, without any slipping. It is telling in the problem, without any slipping. So for horizontal equilibrium, I can say that for horizontal equilibrium, sum of all the forces along the horizontal direction must be equal to 0. Okay, now tell me what all the horizontal forces which are having acting on this one beta. That is nothing but of your N1 and as well as of your N2. N2 is in horizontal direction and F1 is also in the horizontal direction. They are equal and opposite direction. So I can say that N2 is in the front direction. So it is N2 minus of your F1 must be equal to your 0. That means N2 must be equal to your F1. So that N2 is equals to F1 is equals to mu1 into your N1. Okay, so this is the value of your N2. N2 must be equal to your mu1 times of your N1 part of relation. The same way for vertical equilibrium. Right here, for vertical equilibrium. For your vertical equilibrium, sum of all the forces along the vertical direction must be equal to 0. That means I can write vertical forces are what they right now. N1 is in the upward direction, F2 is also in the upward direction, weight of the rod is in the downward direction. So I can say that N1 plus here this one is of your F2 minus of your W must be equal to 0. That means N1 plus of your F2 will be equal to W. Clear? Is it clear? That means N1 I can write the value right now from this one. N1 will be equal to your W minus of your F2. I can write like this. So it is N1 plus F2 value is nothing but mu2 into your N2 will be equal to your W. Okay. So now I can substitute the value. This is the value of your N1. So therefore N1 will be equal to W minus mu2 into your N2. Okay, so this is the value of your N2. Okay. So now from this one, I can get the values of N1 and N2 in the direction. So I can substitute the value of N2 in your N1. So I can substitute this, I'm taking it as of your equation number 2. And this I'll take it as of your equation number 1. I'll say that substitute 1 in 2. Substitute 1 in your 2. So it is N1 is equals to W. N2 value already I got. So what I'll do is I'll take this one here itself. N1 plus mu into N2. N2 value how much I got here? See, N2 value is equals to mu1 into N1. So this one is mu1 into N1 will be equal to W. Okay, so N1 will be common in this one. So it is 1 plus mu1 into mu2 is equals to W. Okay, so N1 is equals to how much for me? Therefore, N1 will be equal to W divided by 1 plus mu1 into mu2. So in terms of your mu1 and mu2, I got the value of your N1. Similarly, therefore, I can write N2. N2 value is how much beta? See, N2 value is how much you got? N2 is equals to mu1 into N1. So it is mu1 into your N1. So that will be equal to mu1. N1 is equals to W divided by 1 plus mu1 into your mu2. That means I can write here N2 is equals to ultimately N2 is equals to your mu1 into W divided by 1 plus mu1 into your mu2. So this is the value of your N2. This is the value of your N2. Clear for everyone? Okay, so this is for the translational equilibrium. So in the translational equilibrium, I got the values of your N1 and N2 part of relations. So that is for your translational equilibrium. So horizontal equilibrium, we got one condition. And for vertical equilibrium, we got another condition. Okay. Sure. Okay. Now let us try to talk about rotational equilibrium. For rotational equilibrium, for rotational equilibrium, that means the body should not be in the rotational equilibrium. What is the condition? You know the condition for rotational equilibrium is the net torque must be equal to 0. For translation equilibrium, the net force must be equal to 0. In the same way, for rotational equilibrium, the net torque acting on the system must be equal to 0. That means I can say summation of the total torque must be equal to 0. This is the condition for rotational equilibrium. Now let us try to take the moment of all the forces acting about this rod beta. Any one point you take, point A or point B. So I'm trying to talk about moments. So what I'm doing is taking moment of all forces acting on rod at any one point. Okay, maybe at A or may other point B. Anything basically. Now let me take the torque about A. Okay, so let me take torque about point A. So torque is force into perpendicular distance, as here. Weight of the body into the యొక్క perpendicular distance. Okay, so this is L by 2. This will be equal to 90. So obviously this value will be equal to your 90 minus theta. Okay, so if it is 90 minus theta, if this is L by 2, so if I resolve this component, this will become for me L by 2 into cos 90 minus theta. So that will be equal to L by 2 into your sine theta. And this direction will be equal to L by 2 into sine 90 minus theta. So that will be equal to your L by 2 into cos theta. So force into perpendicular distance right now. So this is the force which has been acting in the downward direction. So then perpendicular distance will be exactly equal to then good L by 2 kabatti the theta aitunda ikkada. So this will be equal to how much for me? This will become for me L by 2 into cos theta. Vertical will be L by 2 into sine theta. So about the point here, if I'm writing, so it is weight of the rod W into your L by 2 into your cos theta. In the same way, N2. So where is your N2 right now? So N2 into perpendicular distance about your point. So what is the perpendicular distance right now? About the point of here, N2 will be equal to force acting about your point of your here. That will be equal to your L by 2 into your sine theta. See, force into this total will become how much for me? L by 2 into your sine theta. So I can write in the downward direction minus of your N2 into your L into your sine theta. About the point O, about the point O. So if this is L by 2 sine theta up to this rod, this one is also your L by 2 sine theta. About the point A and Kabati, this distance will be equal to your, from here to here, this distance will be equal to your, this is also your L by 2 into your sine theta. So L by 2 plus L by 2, that will be equal to your L by 2. From here to here, this will be equal to your L into your sine theta. So N2 into your L into your sine theta. In the same way, the friction mu2 into your N2, force into perpendicular distance. This is L by 2 cos theta. So this is also L by 2 cos theta. So total distance from here to here will be equal to L into cos theta. So frictional force F2 into your L cos theta. F2 is nothing but mu2. That is in the upward direction. I am taking that one in the minus. So this will be equal to your mu2 into your N2 into your L into your cos theta. Isn't it? That must be equal to 0. Okay, torque because of the F1 will be 0 because it is passing through the axis covered. There is no perpendicular distance on this one. So this is your torque acting on the given condition. Now I know the value of N1, I know the value of N2, just substituting the values will be getting. So now substitute values of N1 and N2. So this will become for me W into your L into cos theta divided by 2 minus N2. N2, how much I got? Mu1 into W. So this one will be mu1 into W divided by how much it is? 1 plus mu1 into mu2. It is 1 plus mu1 into mu2 minus N2. What is the value of N2 we got? N2 only we did it now. So sorry. So this will be into, okay, into your L into your sine theta minus mu2 into N2. N2 is again same. So this will be equal to your mu1 into your W divided by 1 plus mu1 into mu2 into L into cos theta. That will be equal to 0. Okay. So I need to calculate the value of your theta kabatti. So this one is minus and minus. So this will become for me plus. If it goes on the other side, so this one is sine and this one is nothing but of your cos. Okay, so all the cos theta terms I can take on one side and all the sine theta terms I can take on the other side. Is anything get cancelling in this one? You see better. So in this one, L will get cancelled. Here L will get cancelled. Here L will get cancelled. Anything else is getting cancelled. So W. So W also is getting cancelled. Okay. So now you just can do this calculation. That's it. So it is cos theta divided by 2. Okay. And this one is nothing but of your minus of your cos theta. I can take common right now. So this is minus of your mu1 into mu2 into your cos theta divided by 1 plus mu1 into mu2 is equals to. This one is mu1 into your sine theta divided by 1 plus mu1 into your mu2. So cos theta I can take common here. So this will become for me cos theta is common into 1 by 2 minus mu1 into mu2 divided by 1 plus mu1 into mu2 is equals to your, this one is mu1 into your sine theta divided by 1 plus mu1 into your mu2. Okay, so sine by cos will become for me tan. So I'll take this cos here right now. So sine by cos will be here right now. Mu1 will come down and this 1 plus mu1 will go on the other side. So this will become for me. So sine by cos will become for me tan. So I'll take this one on this side. So this will be, this term I'm taking on this side better. So this will become for me 1 plus mu1 into mu2 divided by 2 minus this one is mu1 into mu2 into 1 plus mu1 into mu2 divided by 1 plus mu1 into mu2 is equals to, this one is mu1 into sine divided by your cos theta. So what I can take common here right now, anything is getting cancelled, you see. In this one, into kabatti, this one and this one will get cancelled right now in this one. So it is 1 plus mu1 into mu2 minus of your mu1 into mu2. This total term will get cancelled. So it is 1 plus mu1 into mu2 divided by 2 minus this one is your mu1 into mu2 divided by 1. Okay. I'll take mu1 also here this side. So this will become here mu1. And here also this will become mu1. That is equals to sine by cos. Sine theta by cos theta will become for me tan theta. This mu1 and this mu1 also will get cancelled here right now. So this will be 1 plus mu1 into mu2 divided by 2 into mu1 minus of mu2 is equals to tan theta. Okay, so now you can just take an LCM and simplify it. So we'll be getting this one as of your tan theta is equals to your, so this will be your 2 times of your mu1 into this is 1 minus of your mu1 into mu2. So this will be the answer. Tan theta is equals to your 1 minus of mu1 mu2 divided by 2 into mu. You can just check the calculation. So theta will be equal to your tan inverse of your 1 minus mu1 into mu2 divided by 2 times of your mu1. So that is the answer for this one. If he is asking only the angle, then theta will be equal to tan inverse of 1 minus mu1 into mu2 divided by 2 times of your mu1 particulation. Okay, so just go through this one. And little bit good question. We are having little bit of application of Newton's laws of motion. And this is a regular model better where you generally see the question on this model. So be little bit comfortable and try to be comfortable with such type of your models when a rod is being inclined on this one, on a vertical wall and horizontal surface. Okay. Take care, better. Bye.